In this next equation, it's a little bit messy because substitution is going to require a lot of work and a lot of precision to make sure I don't make mistakes. Elimination might take more steps. So it's a little bit of both. I kind of think since the last example we did substitution, this example we should do elimination. So the most important thing is to get them to look the same format-wise. Right now they don't. The top one is in y equals mx plus b format. The bottom one is in kind of a standard form. So what I'm going to do is I like to, for elimination, put x and y on the same side. So I'm going to take my top one and I'm going to just make sure that I make it look like the bottom one. So I'm going to take 7x from the right-hand side of my equation to make sure that I end up with y minus 7x. I can't combine y and 7x, so I'm just going to write them side by side, equals 12, which is going to be my new value. I'm going to write it in black so it looks like an original. So y equals, y minus 7x equals 12. And I'm going to rewrite my second equation just so I can look at it. I'll put the y value first. Negative 6y, negative 6x equals negative 24. Okay. So the goal in elimination is to multiply one or both equations so that x or y has a value and a coefficient that's equal and opposite. And what I'm going to do is take a look at both x and y. For x, I feel like I would have to multiply both. They are not opposite, they're both the same sign. So I'd have to multiply one by a negative, one by a positive to find the least common multiple of 7 and 6. That sounds like a lot of work. So let's look at y. Well, they're already opposite, and 1y does go into negative 6y. So what I'm going to do is I'm going to multiply this entire top equation by positive 6. So I'm going to do 6 times every single one of these things. And I'll bring that down here to be positive 6y. Do you see how that made positive 6y? So now when I add straight down in the next step, I'm going to have equal and opposites. 6 times negative 7 is negative 42x, and 6 times 12 is 72. Okay, now I did wing these numbers, so I hope they work out. Okay, so when I add straight down, I get 0 y's, which goes away. When I add straight down, I get negative 48x, and that one I'm going to actually take out my calculator for because I can't do that in my head. 72 minus 24, 48. Well, that worked out. Good. Okay. And when I divide through in my equation, I get negative 1. So x ends up equaling negative 1. That was pretty straightforward. I mean, it was a lot of steps, but it was pretty straightforward. I kind of think that was the better option for this problem. So we still are not done. We have to go back and pick our easiest equation. If you look back at our original two equations, and I like to always go back to the original ones, because if I made a mistake at some point in the rest of my problems, I don't want to carry that again. So if x equals negative 1, I think the top equation would be the most simple. So y equals 7 times negative 1 plus 12. Negative 7 plus 12, and that would be 5. So my solution would be negative 1, 5, and if you see, we did a lot of work on that problem. Hopefully it all made sense. In substitution and elimination, this last step here, it's the same, plugging back in the one value that you have. So that's a constant. Substitution and elimination steps are pretty different, but the goal is always the same.